Have a good day, everyone. I'm W.G.D. Nadeeshan from Central Engineering Consultancy Bureau. I presented my presentation about the sewer effluent discharge trains in Colombo Regional Centre area. First of all, I would like to introduce something about what is about my project is. Colombo Regional Centre area is a part of the Open University of Sri Lanka. The Colombo Regional Centre area has several septic tanks already installed during various periods of its development. Even though Naval area is densely polluted, it is not serviced, sewer lines and residential and institutions largely use septic tank socket pit units. These units installed in CRC area are few decades old, and it's suspected that the leakage untreated effluent to the groundwater table. Further, there may be some connections where the grey water is also diverted into the septic tanks in CRC area. A number of septic tanks and manholes in CRC area are overflow to the surface during extended rainy periods where a significant rising of groundwater table is observed. Ponding of untreated effluent causes nasty odor and health hazards in CRC area. This study focused on the establishing groundwater profiles on CRC area, and it's reasonable to think that groundwater table level resonate with the canal water levels. Such a study is unable to determine groundwater contours and gradient during the wet and dry weather periods. This is the basic of my project component. So I would like to overview of my presentation. First of all, I would like to show what is my study area, and also like to tell about my objectives of project and describe methodology what I use and what are the results we can obtain from this project, and conclusion and recommendations. So what is the project objectives? The project objectives are defined in 4 categories. One is to perform a literature survey to identify surface and groundwater contamination potential due to the use of the septic tanks or pit units and the design such units. Second one is to measure the groundwater levels in CRC area, measurements made with respect to water levels in 2 canals. Third one is to measure the parameters of effluent obtained from the borehole wells and canals. Final one is goes to the proposed on-site treatment system based on the information gathered and based on the literature survey. So these are the methodology we have followed for that: establishing the groundwater levels using the temporary benchmark and taking the canals and up and down gradients, and review the available codes and establish the soil profiles and based on the available borehole data. So this is the layout of my study area. You can see that there are several septic tanks systems located in the CRC area. I would like to show that the Department of Health and the CRC building area is the main place in this project. So many students are uses this area to lectures and the study events, so that the densely use this area for over a period of time. So this is the points we can see. I just use for boreholes locations and the rainfall measurements. So proposed boreholes are identified in the blue color, and the septic tanks and socket areas are in the red color. So I would come to the results and discussion. You can see that we are use a borehole location, borehole log for the identify the soil profile. So it is taken from the auger hole, and we are use about 2.5 meters for our project description. So you can see that there is sandy soil and the clay with sandy soil in this layer. So next one is talking about the percolation test results. So you can see that, I would like to talk about these percolation test results. So you can see from the table the variation of the infiltration rates measured the locations, 4 locations. So it is block 1, block 8, block 20 and at CRC building area. So the infiltration rates measured during the wet and intermediate and dry weather period. So locations are vicinity in the socket pits which overflow during the wet weather period. The above values do not fall within the range of 20 to 125 millimeters per hour as recommended in the SLS 745 Code of Practice. They said that standard further requires maintain 2.5 meter height partially saturated zone above the seasonal groundwater table to maintain the efficient soakage. So these are the things these are the things we got from the standard. So I can observe that that are not uh, in the range of our test. So next one is the groundwater table flow direction. So uh, the groundwater table measured using the deep meter readings were used to establish seasonal variation in the groundwater levels spreading over the study period. The groundwater contours obtained during dry and intermediate and wet weather periods. The values indicate that based on the temporary benchmark level of 100 meters taken from the borehole 1. The highest groundwater level was observed at the borehole 1. So the effluent discharge point close to the BH1 is the highest water used by in the CRC area. The lowest groundwater level and steeper hydraulic gradient are observed in the borehole 8, located near the Kirlapana main canal. The main canal embankment, near the main canal embankment. This may be caused the partially treated effluent steeper to the main canal. The observation also shows that variation in the groundwater levels during weather periods range of 99.8 to 97.65 BH1 to BH8. During the dry weather period, we can see that 99.915 to 98.685 to BH8. During the wet weather period, we can see that there is a lower gradient. Another thing is at the partial saturation shown, BH closer to effluent discharge point during the wet weather period, it is nearly close to 0.1.8. This depth does not meet the 2.5 requirement as I discussed in the previous slide to stipulate the standard in the SLS 745 2004. During the dry weather period, the said requirement observed borehole 6 and borehole 8 were located near the canal is good in condition. Next one is results discussions about the septic tank effluents in water quality. So I just measured 6 parameters: COD, BOD, fecal coliform, and electric conductivity, and the pH turbidity are the effluent characteristic we are measured in the project. So you can see that COD values from contours in this present this slide. So chemical oxygen demand of the water samples range between 80 to 335 milligrams per liter, with the boreholes 1 to 1, 2, and 5 and 7 exceeding the values of 250 according to the standard. Next one is BOD values. The biochemical oxygen demand of the water samples range between 48 to 220 milligrams per liter. The boreholes B1, borehole 1, borehole 4, and borehole 6, and the borehole 8 exceeding 100 milligrams per liter range. Next one is fecal coliform. The fecal coliform also range between 19 to 330 mpn per 100 millimeters. So the boreholes BH1, BH2, and BH3, BH4, and 7, and 8 have exceeded the stipulated level of 60 mpn per 100 milliliters in gazetted in the 2008. And next one is electrical conductivity. Electrical conductivity also range between 711 microsiemens per centimeters to 1273 microsiemens per centimeter. So BH1, BH2, and BH5, BH7, and BH8 exceeded the 1000 microsiemens per centimeters according to the Gazette 2008. Next one is pH. pH should be between 6 to 8. Our range between 5.02 to 6.94. And the turbidity also, you can see that it is not in the range according to the standard. It also range between 50 to 100 over 200 NTU. So next one is we have calculated the canal contamination percentage in the 3 seasons of the upstream and downstream levels. We are taking the contamination of downstream level with 3 seasons. All the parameters were increases by the percentage of amount. At the dry season, the contamination was high due to lack of dilution. At the wet season, we can see that downstream contamination is dilution of the water samples. So that we can say that at the dry season, there is a high contamination due to groundwater table of the due to CRC area, not other than the wet season. So finally, I come to the conclusion of my project. So we can say that the groundwater flow gradients are towards the Kirlapana main canal and the upper reach of the tributary canal. This is taken from the groundwater table contours. Next one is the groundwater level during the wet weather period do not provide the partially saturated zone 2.5 meters as required in the 2 SLS 745-2004 to maintain the effective seepage. Next one is measured infiltration rates do not fall in the range of specified in the SLS 745-2004 to maintain the effective seepage. Other one is the measured discharge effluent quality parameter shows significant dilution during the wet weather period. This may attribute the high groundwater levels and the effluent migration towards the 2 canals. Effluent parameters measured during the dry weather period exceeded stipulated values in SL Gazette 2008 for efficient in on-site sewage disposal. These are the conclusions I have made from my